Hi, my name is Edison Mora and this is the project for the Operating Systems course. So for this project there is this company that is trying to design a system to avoid collisions. To do this, they attach a laser sensor in front of the car to measure the distance to the nearest object in front of it, so the car can take the necessary precautions to avoid the collision. However, there is a problem. The streets are not perfect, right? They have potholes and elevations, so the distance calculated by the sensor is not real distance. To solve this problem, the company also introduced this gyroscope, which calculates the inclination angle of the vehicle. So, with these two values, the values from the laser sensor and the gyroscope, you can actually calculate the real distance using Pythagoras. However, this brings another problem. So, the thing is, the sensors calculate their values at different frequencies. So the solution will have to take this into account when calculating the real distance, because in average the frequency of the laser sensor is actually double that of the frequency of the gyroscope. So the solution will have to do the following. So first read concurrently both of the sensor's values. Then calculate the real distance taking into account the different frequencies of the sensors. We also have to initiate, terminate or restart any sensor at any given time. And finally you also have to calculate the response time for each distance calculation operation in the statistics folder. So my solution consists of three components: the sensor program, which outputs the data of the sensors; the lecture program, which reads the data and calculates the real distance; and the main program, which controls both previously mentioned programs. Let's talk about the sensor program and the lecture program first. The sensor program and the lecture program, which I'll call sensor and lecture from now on, are connected by shared memory. And the way it works is very simple actually. Sensor writes the data of the distance sensor in one memory block, and the data of the gyroscope sensor in another memory block, while lecture reads both memory blocks concurrently. Lecture does this by creating two separate threads. Each one of them attach themselves to a memory block and reads the values written by sensor. First, I had only the main thread of lecture reading both memory blocks. But by doing it that way, I found that there was loss of data. In average, I lost 3 pairs of distance angle from sensor, which shouldn't happen in a real-life application because of the safety implications when dealing with a system trying to avoid collisions. So I chose to create the threads from the beginning of the program and attach them to a memory block. So now that I have lecture reading from both memory blocks, it needs to find a way to calculate the real distance. For this, I use two switches, one for each sensor. When a value from the distance sensor arrives, I activate the distance switch. And when a value from the gyroscope arrives, I activate the angle switch. When both switches are active, I calculate the real distance using both values by Pythagoras. This also solves the problem for the different frequencies of the sensors. Because when two values from the distance sensor come, one right after the other one, and the gyroscope switch is still not active, I just keep the last value received from the distance sensor and use that when the gyroscope sends me the next value. Now that we know how lecture and sensor communicate with each other to calculate the real distance using both values by both sensors, we can skip to the next part of the project. In this part, we need to be able to control both programs, lecture and sensor, to initiate, terminate, or restart each one of them. This is all going to be done from the main component, and it is going to be done using signals. So, the main component, main from now on, is going to receive an argument indicating the number of sensors to be created from the start. These are instances of sensor component. So in reality, it will be created a pair of distance and gyroscope sensors. If main receives anything other than a number, it will not run. Also, there is a limit of processes to be created. If the number received by main is greater than 10, then main will also not run. Now 10 is simply an arbitrary number, but the reason is a valid one. There needs to be a limit of sensor processes created from the start because of memory concerns. So, after all the sensor processes are created using fork, then the lecture process is also created using fork. And now we also have in the main component the process ID of all the processes created by main. So now we can use those process IDs which are printed in the console to send signals to terminate or restart any of the processes. So now, for example, if a sensor process is terminated using a SIGTERM signal, then the main component will receive that status and create another process to replace it. If the sensor process was terminated by a SIGINT signal, then the main component will also receive the signal and it will do nothing. It will just terminate the process. And that's it. That is my solution for the